Alright, welcome back. Another video, another piece of junk that's been sat in my container for years. My son bought this. It's a little J-type. It's J-type. 4.5 horsepower. From an estate where it caught fire. It was in a building, and so the building went up. This was a running engine. It was on a wooden chassis. Son made the chassis and stuff, and allegedly in the haste of getting it out of the building, however they got it out, they broke the exhaust valve clean off. But now it's that's a bit shorter than it should be. And I didn't know. I thought these were missing, but my lad obviously bought a pair of valves for it. I'm assuming they're stationary engine parts one, and the guide, because the guide's busted as well. So we have those parts, and we have some serviceable valve springs because I think in the fire, I've been going through boxes and boxes of bits. I think these got a bit warm and shrunk, so they're not like good. We have some correct ones, and I didn't think we had a mag because the fire apparently was here. The fuel tank should be here, obviously not on this chassis because it was wood. I didn't think we had a mag. I mean, not that this is a lot good. I mean, yeah, that's toast. To send that in for overhaul is probably going to cost more than the engine's worth, but it won't run without one of those. So we're going to have to do something. There is a small amount of play. This was the drive side, I think, because I don't know whether you hear it. There is a small amount of play in the crank bearing. Ball's good. Again, this is really badly frost damaged, this one. I'll bring this up here. I don't know whether the camera will pick it up. But it blew its hat out completely. You can see it's been brazed up. I've never seen one that bad before. And this, I remember, so this is years ago, there was a lot of resin inside the block. Because if I zoom in a bit, so here, you won't see it. I'll zoom in so you can have a look. It was being brazed well, that's been TIG welded. So that must have been done later than the top because the top was brazed. But either way, it's broken. And it's cracked away because you're welding cast and it just doesn't work. So my plan is to grind all this out, veer it out where it's cracked away, and probably most of it, and TIG braze it and see if we can do a satisfactory repair. So it was all full of resin, which I do remember getting out. I think that the fire, heat from the fire, and whoever TIG'd that up got most of it and it fell out anyway. Just a bit left in it to come out. That's obviously what they used to seal it up. So what I want to do is get the cylinder off. There's no piston in it. The crank's good. Get it over on a welding bench and we'll get set up and we'll have a go at TIG brazing it up, clean it all up, TIG brazing it up. It does actually say on here Ricardo patent, and half of it's missing. So I'm going to end up, that's going to disappear with the grinder because I've got to clean it all up. But there's not much we can do about that. You know, we are where we are with it. And I need to weld the box section ends up on the chassis, and the fuel tank should sit where all the bits are at the moment. We do have a whole engine. I'm not sure the fuel tank's any good. But let me get set up on a welding bench and we'll have a look at this and see if we can do anything with it. Right, I've V'd all this out around here and I'm going to attempt to just TIG braze these bits across here. We'll skim this in the mill if this is successful. And then I'm going to flip it over because this is the thinnest part and then work my way down and see what happens. We are totally winging this. I have no idea how this is going to go. I've done lots of TIG welding and a bit of TIG brazing, but I am no expert on this. We are literally just winging it, and any snot and contamination here is going to cause problems. But let's just give it a go. I'll just set the TIG set at 50 amps and just see what happens. Turn that down a bit. The idea is to get the parent metal hot but not melt it, and then melt the braze onto the parent metal. It's a bit like soldering but higher temperature really. Let's give that a quick wire wheel and see what we've got. Not quite enough heat there. see what happens. Okay. Probably going to want a bit more heat. Whoops, as I work my way down because it's going to get thicker. Yeah, it's not trying to worry about crazy paving. I'm going to keep going at this. I'm not going to video it all. We'll come back and see how we've got on a bit later on. Hallelujah, finished. That has come up completely different on the camera to what it is in real life. That doesn't look too bad. I suddenly realised I forgot to video all this. I spent hours grinding out and brazing all this in, and I've now just skimmed the head because obviously we had the high spots. I've taken about 20 thou off the head to actually flatten it. Obviously I think it's about 30 thou because I had some high spots there, maybe a bit more. But I might have stick a shim under the base when I put it together. I have to measure the piston crown height to there. But there you go. Next job, hone the bore, recut the valve seats, and the biggest valve seat cutter I've got nearly falls through. So I need to get a bigger one for that. So next job, we'll get set up and get these valve seats recut. Well, while we're waiting for the valve seat cutting tool to come, the right size one, as I don't have it, I thought I'd sort out these crank bearings. This side, which is this one here, there is a bit of wear in it, but nothing to write home about. It's no real big scoring or anything. There's a little bit of wear. I'm not going to worry about the small amount of play. I think if you stuck a 2 thou shim under there, it would improve things, but 2 thou is nor here nor there on the grand scale of things. However, on the other side, which was the drive side, which had more play, don't know whether the camera's going to pick this up because I've done it all now. You can see under there's a bit of brass. I put a 6 thou shim under here, lifted this up, draw filed this off so that when the two halves go together, it's round and this can't move, and it's taken 90% of the play out. You need a bit of free play because these aren't pressurised lubrication. They have a drip feed on the top. Put it around this way. That hole there, when it's this way up, there's a pipe that comes up from the inside and it's pumped and it drips oil into here and lubricates these bearings. And this one, the top one, I reckon some dirt went through it. Get the right way around your plumb. It's not serious, but something went through and picked up a bit in the middle, but the bearing itself's not too bad. But you can see here with the casting, where they were cast, and that just cast, that's how they are from new. This side I'm going to put back together. I've got the crank up on axle stands because it's a split bearing and you've got to get it over this ring. Now this ring is an oil flinger. The oil comes out, it gets dripped in, comes down the crank bearing, hits this, spins out and ends up in a drainage gully and drops back into the sump. I'm going to move the camera around a bit so you can see what's going on, and I'll attempt to reassemble this. They are a bit of a fiddle. Well, I made new gaskets for both sides. Yeah, because you've basically got to put your two halves around that oil flinger, and of course the top shell wants to drop out all the time, just for good measure. So they are a bit of a fiddle. I need to put some oil on it. Right, hopefully, because this isn't too bad, because you can wiggle the crank about a bit, because it's not retained, it's all free to move the other side. It gets a bit more interesting when you're doing, that goes like that, and then that, hopefully, sits in there like that, and then we can bolt it up. And those discs do move on the crankshaft. They kind of, they're not tight, they're stiff, shall we say. You can see, hopefully in the camera, where the paint's burnt off. There's paint from the bottom still there, but all this black here is where it was in the fire. All the paint burnt off, and I am sorely tempted not to paint this engine at the moment. I'm going to get it going, I think. And then we'll worry about painting it another day. Now, I have no idea what the torque wrench settings are for this, probably absolutely none. It's probably just, and that'll be good enough. So, the later engines, and certainly the CSDs, this was a one-piece housing with a one-piece bearing in it. So you didn't have to mess about, because the crankshaft's not reduced in any way or stepped up. It's the same length, diameter all the way down the length. Right. Get that up. You get on there. Alright. I'm going to go and do the other side, and then we'll come back and see what we've got. Right, all I can feel is squidging against the wheel. If I pull, like, you probably won't hear it. So you've got a film of oil between the crank and the bearings, which is what you want. So on this one, I just took the high spots off, because I noticed when you put the two halves together, the bearings didn't allow, this was because it's split, there was a gap, so I just draw filed it off so it would close up. And there's obviously enough just to take out a little bit of free play that was in there, and that 6 thou shim on this one was enough. I need to order some more, but that is free as a daisy. Perfect, that's what you want. On to the next bit. I just put the flywheels on loosely, they're not in, I've driven the keys in home, but really smooth now, no playing it. So I would have said that's pretty good. Yeah, so like I said earlier on, painting it, I'm going to get this going, I think, and then once I'm satisfied that it's running really well, we can always pull the flywheels off, carb off and that, and clean it up and paint it. The engine is clean as a whistle inside. I really don't see the point. No sort of to play out in the crank bearings. And before, if you remember at the beginning, if I could get hold of this, and you could hear it clunk. Well, you can't now. And I say it spins beautifully. So, but on these engines, it's not on here at the moment, but down on this side of the engine, there's a lever here, and that operates a twin piston pump. One pumps all around, one pumps fuel to the carb, and there's no float in the carb. It fills it up to a level of the pipe and dumps back the tank. Now if these engines have been sat a while, all the oil would have drained off the mains. So I normally give them about 30 pumps. Doesn't matter that the petrol's being cycled a bit, to actually pick up oil from the oil pickup, go right round to the pump, then back, and then internal pipes up to all the bearings, and then it drips down on a splash tray where the dipper picks it up and flicks it round on the big end. It doesn't actually dip. The dipper doesn't go into the sump where you can see the oil. So you need a residual on that tray, sort of pan in there. When we put it back together, I'll show you. So I always give these plenty of pumps on the old oil pump to make sure everything's well lubricated before we start. So now it's back to waiting for the valve seat cutter so I can finish the block off. Well, what's in the box? It's certainly not ice cream, I'm pretty sure of that. Not judging by the smell of it. Yeah, what's in here? I have, oh, hello. Yeah, I don't think that's a lot of good somehow. That's obviously the mag drive chain. Yeah, that's not a lot of good. Oh, okay. That's the stuck carburettor. Soaking in diesel. Anything else in it? Oh, yeah. Yes, I think that's a governor spring. I don't think it's going to be any good either. Okay. And we have a push rod. All the rest of this is over. I think we need to clean this up a bit and get this stripped out. Oh dear, oh dear. Oh, I don't know how many years that's been in there, but it's been more than a week, that's for sure. Yuck. Right, let's give this a rinse off. I think we'll safely call the mag drive chain done. I think we can get one of those. See me drying this off and chucking it in the shop blaster. Yeah, she's stuck. You might need a bit of persuasion with the old heat. God, I don't know how long this has been in there. Because I've got all of it. I know we've got all of it. It's just getting all the gunge out. Yeah, I think what we'll do, we'll warm this up. See if we can get it apart. I wonder how worn these holes are. Because quite often the holes in the end of here, which connect the governor rod and your throttle slide that goes up and down, they get really worn and they don't regulate very well. So I can see. God, I wonder if it just got soaked in fire extinguisher. Because this engine was, you know, how that powder and then it gets wet. So corrosive. And boy, oh boy, wow. Yeah, I think we might have to get set up on a welding bench and adjust that with a bit of heat. Holes look fairly round though, which is a good start. Yeah. Yeah, I think we're going to pull that apart and shop blast that, I think. Thought we'd get a bit more done on the bottom end. Obviously I didn't take this engine apart, so I didn't know which nuts went on which bolt, and they're not always marked. I don't know whether the camera will pick this up, but these two halves are marked 0, 0, so it goes this way round, and then you've got a 0 there, and there's a 0, if I find it on the nut, I know it's there somewhere, just about see it. So all that lot went together, simply because there's a hole in here for a split pin. And whoever did it would have done it up tight and done it by hand. So if you put the wrong nut on, the holes won't line up. And also, these are shimmed. If I take this apart, I went to put this in the vise to do them up tight and see what lined up, and it turns out that they were marked on this occasion. If I take this apart, shims now fall on the floor. Come here, you. So they're the shims, and the idea is that as the big end wears, you change the shims, and there was 2 on one side and 3 on the other, and 2 of them had a very distinctive crease, and 3 of them had a very distinctive crease in them, so I knew they all went together. And Look at that, they are pretty flimsy. They go like that. There's a bit of wear there, but I'm going to put this together and do it up tight and see what it feels like. Now, Plastigauge, which is the way you measure the clearance we use today, which is a plastic material of a known dimension. You cut a strip off, lay it in here, put your assembly together, squish it up to the right torque, take it apart, and of course it squidges out. And there's a chart within the Plastigauge, and you can measure it. Well, Plastigauge, as far as I can find out, was invented in the 1950s. This is a 1930s engine, so they didn't use Plastigauge. It is what it is. So let me sort of set the camera up a bit better. Hopefully you can see in there a bit, and we'll have a play with this and put it together. It's going to be interesting to stop these shims dropping out, but maybe a bit of oil on it will help. I know this isn't a great view because all this I just can't get in there. So basically, put the, say this is where the shims drop out. I have slapped a load of oil all over everything to try and hold it all together. And I'm doing it without the piston on the top. It's just a load of extra weight. I'll put all the things marked with 0, obviously, together. Let's see how many shims we can drop on the floor. It goes up like that. There's me 0, there's me 0. I'll stick that there like that, and a nut with a 0 on it. That's not that one, must be that one. Probably can't see a lot of my fat head in here. And I'm just going to do this up tight and then give it a tug and see what it does. And if it feels good, we'll go with it. If it feels sloppy, I'll take a shim out. And that is literally how you adjust them. And being there's very little wear in the shells, there's a bit of wear on the top one, which is the one that always wears, because obviously when the engine fires, it's at the top of the stroke, so it's forcing it down, so that's where you get your wear. What's the torque wrench setting for this? No idea. I doubt if you'll ever find one. I'm going to have to go and get a socket for that. Of course, that's 7/16 Whitworth. Basically, you just got to line up the split pin hole. And see what it feels like. Yeah, I'm going to take a shim out of that. Because we've got 3 on one side and 2 on the other, so we'll whip one out. I can feel a bit of play in it. Being with a bit of play in the crank bearings, that's probably not surprising. You need a bit of clearance for the oil, like I said before, but because I won't know where that shim's come from. This is where we drop all the shims on the floor. Let's have a look. Oh no, that's fine. 2 on each side now. That'll work. Let's try that. I keep the shims. I have a box full of them from various engines I've done over the years. Right, let's see if we can get this back in without dropping shims all over the floor. Right. And you just keep going like this until you get it so it kind of feels about, kind of sort of. And it would run with it just might clonk a bit, that's all, if you've got a bit too much clearance. But alright, split pin holes lined up. Let's see what it feels like. Yeah, that's a bit better. Yeah, I can just feel a bit of oily squidge there I don't want to take out any more really. Yeah, we'll call that good. I'll go and find some split pins and put those in. We're still waiting for the valve tool to turn up, valve seat cutting tool to turn up. Put a bunch of split pins in, that's as far as that goes on that bit. And I will put the piston on and then we can build it up from there. Well, we have progress. Valve seats cut, valves in. Now I had to shorten the old guide because these valves are 15mm shorter than the originals because these are early J-type and B-type valves. Right size head, right size diameter stem, and the new guide was slightly shorter, and I'd use slightly shorter valve springs. These are actually CS diesel valve springs, the inner valve springs. They have dual springs and they're 15mm shorter than the originals because you don't want this lot to bind up or bottom out when the valve's lifted, and these lift just over 7mm, about 3/8 of an inch, give or take, and I've actually got 15mm travel, so I've got plenty of clearance. But you'll see on the block when we get to that point, I'm going to have to make longer adjustable tappets, and believe it or not, the original ones are soft. I thought they'd be hard. So I've got some 5/16 Whitworth by 2-inch bolts coming, 8.8 hardness, which I will skim the top, so take the numbers off, and I'm going to case harden them. But we'll go through that when I get to that point to give me that, because I've got that 15mm difference. The valve lift is still the same, it's just I've got a bigger gap because these are shorter valves. And then if I swing the camera around to the lathe, here we go, and pull that in there so you can see it. Don't know whether you remember from the early part of the video, the original fuel tank caught fire in the fire, and I zoom, whoops, come here you, zoom out a bit, that there, this stupid thing will focus, there you go, that fitting there, this is another tank I've got which is absolutely shot, I've got to make a new one, that fitting there is missing. It's obviously the solder came undone in the fire, so I'm just machining another one. I need to part this off and leave it slightly long because I'm going to put a little spigot on the bottom of it so it sits inside the tank to give it a bit more mechanical strength. So that's the next job. And then I've got to make the ferrule that goes on the end because it's cracked. Bring this up here. Zoom it out a bit. You can get the crack around there. I don't know whether this is picking it up because I can't see. But yeah, there's a crack in that. And it's all come unbrazed, this is brazed on. Now I can find these, 1/2 inch BSP, this is 1/2 inch pipe with a nut, but I couldn't find that tank fitting, so hence I'm going to make the pair. There's no point having this equipment if you don't use it to make stuff, especially as I only get half of what I need. So yeah, I'll get on and make those bits, and then then I've got to make a tank. Well, the stupid camera will focus, there you go. One tank fitting made, 1/2 inch BSP, and that is a 60-degree taper, and I'll put a little spigot on the bottom so when that goes in the tank, it'll go through the tank and give it a little bit of a location, and then I'll solder it on. Now I can't use the one I showed you on the other tank that I've used as a pattern because that's off another engine and I need to make a pair of tanks actually. So next job is to make the ferrule that goes with this, and then we'll have a pair of parts. Well, there you go, the stupid thing will focus. One ferrule, I haven't soldered it on here yet. Because I may end up having to make another pipe, because obviously I cut the end off of this to remove the old ferrule off. So, but there you go, a bit of brass in a lathe, and you make yourself some tank fittings. Pretty straightforward. And that, now the next bit is to make the two tanks, because I need one for this engine and one for another one, so I'm probably going to end up making 2 tanks together. Will you focus, you stupid thing? And that's a good fit push on there because I drilled a 1/2 inch hole in there. So right, next stop, let's make a tank. Now I just finished making the fuel filler now. I made one, this original tank. I went to take out the old fuel filler next. I think the fire must have done, the brass is really brittle and it's just fallen to pieces. That one there, which is the fuel out and it has a piece of pipe on it, I managed to get out, and though I saved it, I wasn't very happy, but I managed to get one. But I couldn't get a fuel filler neck And I'm only putting one on it, so I just turned one up while I was making a mess with brass before I go on to the next job. Focus, there you go, and that's one of the original fuel filler caps. I actually made out a bit of leaded bronze because I run out of brass, but I had a bit of right size. So that's made, and I did the return as you saw the other day. So I'm not going to go into making the whole fuel tank. I've rolled up the cylinder and put an end on it. I need to drill a hole for the pickup and drill wherever I'm going to put my fuel filler and obviously the return, and then I'll weld the end. I'll solder this one in first, weld the other end on, and then solder these. Hopefully we won't get too much heat transfer and melt the solder. Might have put a wet rag around it, and that will be a new fuel tank made for it. I haven't videoed doing that. If you want to see how I make fuel tanks, I think it's part 2 of the WD1 resto. Is me going through making a tank and pressurise it, make sure it doesn't leak. So if you have a look at that, that'll show you how to do it, and I'm going to crack on and get this bit finished. Right, we got updates. Fuel tank is done. I welded some, originally this would have been wood, the base mount and all this would have been wood. I made it out of steel. I welded this on, I pressure tested it again to make sure it don't leak, and it's fine. I can't fix this down at the moment. It'll go there somewhere because I need to put the oil stroke fuel pump in and the carb on so I can make sure that return pipe fits, or I might have to extend it to get it where I wanted. All the pipes are good, they seem to survive the fire. I made some spaces to go under it. I'll zoom it in, I'll show you what I did, because our valves were slightly shorter, so I'd extend the push rod effectively. I want to zoom in a bit, get a better picture. Right, there you go. Those bits there, because these bolts are 5/8 of an inch longer than the original, so I made a spacer, and I machined, because they're modern bolts, they're Whitworth, I machined the numbers off the top and then case hardened them, because the original ones were soft, which I thought was odd. Valve clearance wise, I don't have a book on this, and all I can find on the internet is 10 thou and then sometimes 12 thou when hot, or 8 thou when cold, 12 thou when hot. So I set them at 10. It's a starting point. Let's see where we go. But it all works as it should. I've timed the mag up. So I now need a head gasket, and the one I ordered from Stationary Engine Parts is for a L-type. They don't do one for a J-type, which is smaller. Same style, but so I've got to send the old gasket away and get it done. And then we'll come back when I've got that, and this should be very near complete and then ready to run, which would be pretty cool. Well, been busy. Quite a lot's got done. Fuel system's done, oil pump's done, it all works. I'm going to get the camera around and show you inside the crankcase so you can see what I meant. This like double sump arrangement. I've sent away for the head gasket to be made, and I thought it would be a couple of weeks, but it's actually going to probably be near a month, so we're still a couple of 3 weeks away yet. And I run out of fittings for this bit, and I've got some matte silicone hoses coming, and there's also I've got to weld a fitting in the bottom to put a gate valve in to let the oil out. So what do? Do we do a part 2 of getting this running, or do we wait 3 weeks and I upload this video? I can't make my mind up at the moment, but I'll move the camera around and I'll show you inside the torch the crankcase with this double sump affair. If I shine the torch in here, that bit there you can see is not the sump. The sump is down there. That is a shallow tray, probably not more than ½ inch deep. When the dipper comes round, it dips in the oil that's on that tray and splashes it around, and that is fed from the oil system where it's sucked up from the sump, goes back to the pump around these pipes, and then lubricates the bearings, and then the excess drips down onto that tray. Well, if you've been carting this around and moving it around, and all that's run off, and then you fire it up, you could find yourself running a big end dry. So that's why I always do like 20 or 30 pumps, generally 30, maybe a bit excessive in most people's eyes, but at least it guarantees there's plenty of oil on that tray in there. So now I can button this up. I also made a new bit for the starting handle. I managed to get a roller for it, a proper, apparently there's a genuine Lister ones off Evil Bay. I had to make a new shaft because obviously this all got burnt in the fire. Right, I'm going to call that it for this video. I made a decision, we're going to have to wait another couple of 3 weeks to get the head gasket sorted. So we'll call that it for this video, and you're going to have to come back part 2, which I was trying to avoid doing with this one. I was trying to do the whole thing in one video rather than 2 or 3 parts like I normally do. But because I haven't got the head gasket yet, I just didn't order it early enough. We'll call that it for this one. You'll have to come back in the next video and see, well, did it run? Did I put it together properly? And does it run any sense? So I'll say thanks for watching, and we'll see you in the next one.